Welcome to this demo presentation of onboard your security team in your Kubernetes journey. The idea of this video is to demonstrate how you can use existing Fortigate features on VMs or hardware to protect a Kubernetes environments, allowing your security team to use the tools they know and understand and trust, while allowing the Kubernetes developers and orchestration and operation to not being blocked or limited by the security. Let's get started on a little refresh on what are the security issues and models for that. When you talk security, we usually use what we call threat models to illustrate and depict the different pieces and parts of a system and the communications, which are usually what we call the attack surface. The gray lines are basically the attack surface, and where you need to place your security devices, solutions, etc., to protect those environments. So this is coming from directly from the CNCF. CNCF also directly recommend to protect your API server and to firewall it, and to firewall your nodes network. So we're going to see that in the demo, and what it looks like and what you can do when you follow those recommendations. One important part here is to really realize that there is a lot of communication from the users and the user responsibility in the share model, because the users are roots even in a managed Kubernetes on their nodes, and the nodes is a VM with all the container D, etc., and all the process here, and those processes have access and can do and ask the API servers and the scheduler to change and do things. Same for image, manifest, and blobs, etc. And this is very important to understand for the security people, and this is their language. If you are more of a developers and you don't get this, you need firewalls and security team to protect you, because people and many people like Google with their Beyond Corp tries to avoid the firewall layers of what they some think is the past, but that means all the security provided by our security devices you will have to implement in your own code, and in this code that is not yours, coming from from the Kubernetes environments, and it's not that easy. For example, one of the recommendations is to disallow one of the tool coming with most Kubernetes, which is the dashboard. In a serious production environments, you should not put the dashboards showing you. It's not easy to write a code that is secured by itself, and if it's not secured by itself, someone else needs to help you. This is what you're going to see here today, and or we can help you without blocking the goodness of orchestration, scalability, and lifecycle coming with Kubernetes. We'll set the scene of this demo here first. We are going to show you a demo on Azure and using AKS managed Kubernetes. Nothing we do is too specific about that, but we need an environment to try and test and show things. So we choose that one because also because AKS has new features for making your managed AKS more private APIs, private registry, private etc. You really have to understand here that it is not private as private cloud, but private tenant as your tenant, as your own data can be put in a VPC and not directly on the internet, and because of that we can protect it the same way we protect clouds for years, and that your security is okay with that. So everything of this demo is available on the internet. You can see the code, you can see how I do all those things, and you even have a Docker image with all the CLI commands. Basically, if you want to redo that yourself and use the code, you need to have AZ CLI from AKS and Kubernetes kubectl CLI and Ansible also. So you will all get all that there directly. And you will see also an example of how you can use SSL inspection. So use and make a Docker instance really use and easily as a value, as a environment variable SSL inspection, which is done using interesting specific CA certificate authority. Once you're done, it's basically deploy this, and this is what you have in a drawing. It takes some minutes, so it's already done here, and that's what you get. So here you have internet, Docker Hub, etc. on there, a load balancer, 2 subnet in 1 VNet with Fortigate, FortiWeb, routes, internal load balancing, and we use peering to peer with the AKS private API and options in AKS deployment, and AKS with CNI, the full AKS deployment with using the AKS CNI plugin, which basically means every pod has an IP on that VNet, which allows us to really do stuff. For people who worry about scalability, this is the same way we have scalable up to 16 Fortigate. So we scale up more CPU and scale out more instances. So you can reach multiple hundred of gigabytes of traffic, and you will see also that what we do here can be adapted to the rest. After that, once you deploy your AKS and everything in there, we do recommend, and Fortigate provide you this, to VPN to your environments, which I did here. Of course, Fortinet provides you FortiClient, directly available client to connect back and VPN to that environment. And the dashboards, we just remove it and use Lens. So you can find Lens easily on the internet. Lens runs locally and only use the API, which avoids to have non-secure service running on your cluster. But here, because it's fully private, the risk might be low if you don't allow too many people to access your dashboards. And that's it for now. Let's go and see what we deployed here. So we deployed the Azure Vault back and front, and the Fortigate controller. So you have this very well-known deployment of Azure environments. What we did with the controller, and you can find the controller, and you can see it's running here, and this is a public IP address, but it's actually the same IP address of that you have on your Fortigate. The thing is, a Fortigate can act as a load balancer itself. So it's not the point of a Fortigate to replace or to be load balancer only. The goodness of placing the Fortigate and controlling it from Kubernetes as a load balancer is that you will get all your traffic from the outside, from the internet, and you will be able to adapt the load balancing to the different services it aims to attack. And we did a demo code showing you the capabilities of Fortigate with a Fortigate controller. And you will see, and you can see and have a look at the code. So this code is already deployed. The only thing you have to do is really to add annotation to your services. You can choose and have multiple FortiGates. Again, for scalability, it's a very nice thing. And then the controller will take care of load balancing. You can see here the FortiGate is load balancing to a service, and you can see the service going on here. What's important here is you can, from your kubectl environments, scale. So you can see it's been scaled. And if I just go there, I can see my load balancing is now going on to all those different pieces and parts. But then you simply have a load balancer. And what is important in there is you not only have a load balancer, you also have a full-fledged firewall protecting you from DOS attacks, protecting you from malware, etc. So we can go in there and see the rule, and the rule has been created from Kubernetes. It's from the Kubernetes controller. We created that rule, and we can add more profiles to protect, and the way we protect HTTP service, for example, for IPS, intrusion protection, app control, etc., can be done there. Even SSL inspection, especially as you can be the SSL endpoint. Oh, by the way, let's go do that. As you've seen here, I'm using it's HTTP for the voting app. I can, from the custom resources, go and see that I have a Fortigate load balancer in there, and you can see I see those 5 different instances at the moment, and the 5 out of 5 is it's getting from the from the Fortigate itself, because we have health checking that the services are up in addition to the rest for redirecting the traffic. But let me do something that is usually takes quite a while to make it right, with full secrets and proper setup to make your service TLS, HTTPS fully, having your private keys managed in your Kubernetes environments. You said you probably need to, and you have to, install a proper secret management, Vault or over public clouds. You have to get your private key secured. Then your security team have to deal with that and check, audit your development process and your operation process to make sure that this private key is not moving around and being used by bad actors. Here, I simply said in the custom resources, switch the load balancer to use HTTPS instead. So I will have the same load balancing capabilities. And now if I try to do that, it doesn't work anymore because I need to do HTTPS. And now I have HTTPS. My Fortigate is the endpoint with certificate management. We also support HSMs, but your security team is in charge of being the TLS endpoints, and there are much more. They can also inspect the traffic after the TLS endpoint and provide you a lot of security for that. And all that has been managed, and if I go to my virtual servers, all that has been changed by the Kubernetes environments, meaning that we really, with that controller, connect what the security layer needs to know about the service, and automate the changes that Kubernetes can do, scaling out, with add-on of security for the rest. It was only one line of annotation globally in the services, which makes the ingress traffic getting into the cluster under control with the tools and the security you already know, and your security team knows, all that being able to really do the life cycling and all that. So this is how we envision and want you to unleash your some of the deployment have been stopped sometimes because of security. So this is a good way to really get faster. In that sense, you can move with these environments much faster because your security team will be comfortable with that approach. Now let's go to the egress. So that is the opposite sense of the traffic. So for the opposite sense of the traffic, which is egress, it's traffic initiated from either the nodes or the pods. So it's the traffic generated from inside your Kubernetes cluster to pull an image to start it, for example. We enabled on this demo the SSL inspection by enabling the CA. You have in this environment, if you want to test it yourself, you can have all the different scripts to help you do that and show you how you can do that. This can be, of course, adapted to your way to deploy your Kubernetes environment. Let's go see the policies. So for the egress, it's everything coming from the Kubernetes network, subnet, and going out. I will enable SSL inspection to custom deep inspection and all the other features, especially antivirus. So again, what you see here is something we do in next-gen firewalls and advanced security features, providing in-traffic antivirus, web filtering, application control, intrusion prevention, dedicated denial of service policies, logs, and etc. etc. If you avoid this type of protections from a vendor, you will have to implement all those things yourself in your code, which only a few set of people can do. And even if it's implemented in your code is going to run alongside other code in container environments. Again, if you go back to the threat model, this isolation is not as good as VM isolation, which is not perfect either, because you can have dedicated and shielded VMs on public clouds. So this shows you that dealing with this part of the security of a Kubernetes cluster is hard and long-term thinking if you want to do it yourself. We are fine with that. If you want to do it yourself, we have plenty of solutions for analytics, SOCs, etc. that can be used. But if you didn't already start, it's a multi-million-dollar and multi-year journey. So if you're ready for that, good for you. So let's try to see if this provided a little test Docker image, and will work. So let's see if this pod is going to run. No, it has been blocked, and it has been blocked by the firewall because ACAR is a test file, so you won't screw your environments if you try that. And it's an image provided with the Docker file, so you can see it if you are afraid. But you can see here that the image did not reach the VM or the node itself. So no risk of getting anything damageable from threats are here from the internet or for any registries you may want. So you see that the firewall did treat it as a virus in that Docker image and block it, which result in an error on the Kubernetes deployment because you can't pull that image. By the way, our Fortigate allows you to create security profiles to really see the Docker traffic itself. So you can really let's see that here. You can see that my Docker pull blob was forbidden, meaning that the antivirus was triggered by the blob, by the pull, and not by the manifest. The manifest was clean, and we can see here also some of the traffic to the rest of the environments. This means we can really create a policy based on Docker pull and push, so you can really segregate your traffic the way you need and you want, adapted to your environments, even from the perimeter of your Kubernetes. This is allowed because we enabled in the AKS cluster to use the route and the user-defined route to get out. Let me show you what it looks like, because all the code is available, so you can actually see the code for the more curious of you. You can see I have many demos there, but it's in the way we deployed the AKS is using private cluster with Azure plugin. All that makes sense. Calico, which is a good partner of us, autoscalers, and user-defined routes for the Ubuntu types. So then you can add a route to your environments to use the Fortigate as your egress for all the nodes and the pods. You should not use SSH key, but this is a demo learning environment. So I did that so people can go and see how it works on the VMs, etc. In production, you should avoid that, and you can block it from the Fortigate or detect it from the Fortigate as a bad thing happening. Okay, next is getting deeper into the traffic in between the nodes themselves. And to help do that in a meaningful way and to adapt to the automations, the Fortigate have a Kubernetes connector. So you see it's up and running. And it's connected to the internal IP address. Again, the API is inside the cluster. what this allows me is to create objects, addresses. That was an old one, but as you can see, I have here a dynamic result, and here that is my vote, front and back. Let's scale it again. So that you can see the vote front now resolved to a big list of endpoints. 10.8 is the internal IP. That is a construct of Kubernetes. As you can see, the Fortigate can see that too, because it's due to the peering, and the DB stays the same. What this allows me is to create a rule between a dynamic address, which is the front, so everything initiated from the front end trying to go to the DB, I can catch that traffic and I can, for example, deny it. So you may say, oh, but then what happens if those two pods ends up on the same node? Then in that case, I can't see that traffic. But you can easily, when you deploy a service, let me show the service. It's on the deployment. Yep, it's on the affinities. So you can create an anti-affinity rule and ask that your front service do not go on the same pod where you have your back service. And if you, it's a very it's a feature from Kubernetes. And if you do that, then you force the traffic to go in and out the nodes. And because we can do that, then we can see and deny it, which allows me to show you that the traffic is blocked. It doesn't work anymore, whereas the load balancer still is there and still work. But even if I go to the load balancing, because I enable probes, the probes are down. Probes are ways on the load balancer to be much more advanced than just being up. You can do, for example, an HTTP GET and be sure you receive a certain word or certain thing, so you know that the web page is up and the one you expect. It's not the case here because we blocked the connections between the back end and the front end. The thing stopped working. So let's re-enable it again. So you're confident I'm not cheating, and we will see the traffic going up again if I disable that policy. Up, back up, and the load balancer monitor is back up again. As you can see, it's up. If I go to the custom resources in Kubernetes, which is what the developer, the controller maintain in there, the state of this. So this is a direct information we get from there. So if I create that policy and block it again. So it's done, and you will see it's 0 out of 5 here. So it's a direct connections between Kubernetes custom resources, which even all the public clouds use for their own load balancing. But you can see that placing the Fortigate at the load balancer place allows and the connections with the connector and the egress allows to do a lot of the usual way and the usual security teams. You don't need to get new tools, get them approved, get to the SOC, and ensure that the developers in charge of security. Because if you remove all that, you push your security responsibility much more on the developers and much more on having the security experts and developers have to deal with that, work together, make sure all the code deployed on the Kubernetes cluster that is fronting the internet has the same quality as basically a firewall as ours. Happy if you go there, then you don't need us, but it's usually reserved for what the public clouds like Google and with their Beyond Corp are pushing. We don't think you need to reinvent the wheel, because at the end you will spend a lot of efforts and money to go back to what you already get with the FortiGates you already have, or you may want to adapt to that. Same on the egress. We can create a lot of different policies, meaning we can create a dedicated policy from a service, a front end, to an external database. In many cases, people don't have their database in their Kubernetes cluster, or they use other tools and APIs from other vendors, like voice recognitions, like any of those things. And because of that, you can, with the way we've done it with SSL inspection, have advanced protections, including data leak protection. And this is the end of this presentation, so hope you enjoy it. Just as a summary, we showed that with making Kubernetes cluster, here it's AKS, but it works for nothing was too special about that. With the existing security layers that can scale, also you can have multiple FortiGates here, and you can create multiple rules and FortiGates to your environments. So small or large, you can really segregate the different traffics, create policies based on naming and not on IP address, which is what you usually want. Even showing you that using an external tool, the controller, the use to Kubernetes orchestration environments can really replace the default very limited load balancing with a full security features, allowing to be the TLS endpoint very easily, making sure your security team is comfortable with that approach, etc. In the next round, we're going to dig into FortiWeb as an ingress or as a Docker image that you can deploy on your Kubernetes cluster for API protections. But that is a subject of its own, so stay tuned for the next. Thank you for listening, and hope you enjoyed it.